So we're going to integrate this function here. It's all enclosed in a square root. Hyperbolic tangent to the power of 4 plus hyperbolic sine squared divided by the hyperbolic cosine to the power of 4. And then that's all with regards to x we're going to integrate by. And the parameters 0 to 1. Okay, so before we integrate this, we need to work out on some trig identities and some use of maybe. So first of all, this one takes my eye here, is the tangent to the power of 4. So the hyperbolic tangent works the same as the normal tangent. So tanh of x equals sinh of x over cosh of x. And now we can raise this to the power of 4, as in here, like this. And this identity will still stand equal. Okay, so let's put that in there and see where that takes us. So 0 to 1, square root. Now I'm going to put this in here now and put the power of 4 on each. So sinh to the power of 4 of x over cosh to the power of 4 of x. So we haven't changed the value of this. And then put in the other term, sinh squared x over cosh to the 4x and x. Okay, so now we're moving forward. We've got a common denominator here of cosh to the 4 of x. So let's restart a new line here. We'll do some more working, see if we can work some more trig identities. So common denominator, cosh to the 4 of x. Now we've got sinh to the 4 and a sinh to the squared. So I notice that if I square this term, I get this term. So we can use a trig identity of cosh squared x minus sinh squared x. That equals 1. Okay, so maybe we could use this somehow in this numerator here. So let's factor out a sinh squared x. So if we do that, we've still got another sinh squared x to go here. And then here we just need just plus 1. So you've got the plus sign here, and that's just one of those. Okay, now if I just move this around here, I end up with cosh squared x equals 1 plus sinh squared x. Now that is the same as that. So what I could do now, I could put a cosh squared in here. And then I could perhaps do something with these as a cross cancellation. So let's put that in on the next line. So still in the square root. Seems to be going forever with that square root. And now we've got cosh to the 4x, sinh squared x. And then instead of sinh squared x plus 1, I'm going to put this one in. So now I've got cosh squared x. Okay, so now I've got these two terms in the top are multiplied together, and this is just one term on its own. So now I could divide cosh squared x top and bottom. So that would then cancel out this whole term and reduce this power by 2. So that 4 would now become a 2. So now we can simplify this even more. Now we're getting a smaller term even. So sinh squared x over cosh squared x, which we know from here, this is just going to be tanh squared x. So now let's bring this up over here. So now 0 to 1 square root of tanh squared x dx. Now this is looking very promising because we got a squared term inside a square root. So they're inverse of each other. So now I can just cross that out and cross that out. So now we're left with, from 0 to 1, the integral of hyperbolic tangent of x dx. Okay, so now let's rub this out, carry on over here. Let's start back on from there. So from 0 to 1, tanh of x dx. Now I can revert this back to the sinh and cosh. So 0 and 1, sinh of x over cosh of x dx. So now to integrate this, we can now do a u sub. So I'm going to do u equals cosh of x, so du equals sinh of x dx. So therefore my dx is du over sinh of x. So just bringing that across. So now if u equals cosh of x, so what's cosh of 0? So cosh of 0 is 1. So here I've now got, so using this cosh of x, so u equals cosh of 0 and u equals cosh of 1. And now using the u sub, I've got, just going to write this in here now, sinh of x over cosh of x, which is my u. I'm just going to write it like this just so as we can see the cancellation here, and then du sinh of x. So now we can see that the sinches cancel. I wouldn't normally write the x terms in with the u because it's not in the same parameter, but now we can see that this is just 1 over u. Okay, so now we've got u equals cosh of 0 and u equals cosh of 1, and then we've simply got 1 over u du. So integrating this, not a problem. So that just becomes, so now we can just go along here now. So now we can just go natural log of u, and then our parameters are from cosh of 0 to cosh of 1. Okay, now let's go on here. Okay, so plugging in cosh of 1, so we've got ln cosh of 1 minus ln cosh of 0. Okay, now what can we do here? So we've got ln cosh of 1 minus ln cosh of 0, and absolute values, we know cosh is always positive, so we don't need these absolute values in here now. So now what we've got is basically ln of, just write it as a bracket, cosh of 1 over cosh of 0. Now cosh of 0 we know is 1, so this one is 1. So now all we're left with is ln of cosh of 1. So just write cosh of 1 in there, and that is good as our answer. But we can simplify that up even more or turn it into an exact value using exponential. So we know the identity. Let's just write this over here now, just to go through this last bit. So we've got cosh equals 1/2 e to the minus. Now if this angle here is theta, we've got e to the minus theta plus e to the theta. Now for this term here, for theta, we've got 1. So basically what we say is cosh of 1 equals 1/2 of e to the minus 1 plus e to the 1. So which is 1/2 1 over e plus e. Okay, let's see if we can just multiply top and bottom by e on this side. So if we take this and multiply it by e over e, that way then that just becomes 1. This becomes e squared over e, so it's still e. So now we've got a common denominator, so it's 1/2 1 over e, so that's that, and then plus our e squared. And that's basically our cosh of 1. So if we take the log of this, so therefore our integral, so ln of cosh of 1 equals ln of 1/2 of 1 plus e squared over e. And then that's our answer there in terms of logarithm and exponential. We can do one step further, ln 1 plus e squared over 2e. And that will give us our answer to our integral.